Everyone and welcome to UK Foundations. I'm Uthara Adithi and this is the third video on chemical reactions and equations. So hopefully today we'll complete the video, so let's begin. The first question, why do fireflies glow at night? Okay, so the answer to this question is basically fireflies are going to secrete an enzyme called as luciferase. So this enzyme will react with luciferin. Basically it is like oxidation of magnesium. You know oxidation, right? So this is magnesium plus oxygen gives rise to magnesium oxide. Forgive the writing. Okay, so it's not balanced, you can balance it, right? Drop a 2 here and a 2 here. So this is the oxidation of magnesium. So this is the reaction that's taking place, and as a result some light energy is going to be emitted. So we are able to see that light during the night. So it's seen as a glow. Okay, so moving on to the next question. Right. Grapes hanging on plants do not ferment, but after being plucked from the plants can be fermented. Under what conditions do these grapes ferment? Is it a chemical or a physical change? Okay, so for this question the answer is that when grapes are still on plants, right, basically their self-defense mechanism, kind of like their, you can tell, immune system is very active. They are very active that they do not allow any kind of fermentation reactions, any kind of these some kind of external reactions to take place, external agencies to do any kind of reaction. But once you pluck it, that kind of agency or that kind of mechanism stops working. So yeast will carry out the fermentation. Okay, so we know, right, the let me write it down. Yeast, it's very bad writing, I know that. Yeast will carry out the fermentation. What will happen is sugar will convert into alcohol, and definitely it's basically to form alcohol, right? So it's a chemical reaction, it's not going to reverse back. It's an irreversible reaction and also a chemical reaction. Moving on, let's take another color. Oh, fine. Okay, right. Which among the following are physical or chemical changes? I have said already the meanings of physical and chemical changes, right? Basically physical changes are those which are irreversible, chemical changes are those which are reversible. Irreversible chemical changes. Okay, so evaporation of petrol, that is a physical change, right? Evaporation is a physical change. Burning of liquefied petroleum gas, so LPG is burning, it is not a physical change, it's a chemical change, irreversible. Okay, heating of an iron rod to red hot, so it will cool back, so it's reversible, physical. Curdling of milk, definitely to form curd, it will be a chemical change, it's irreversible. Sublimation of solid ammonium chloride, what is sublimation? Conversion of solid to gas directly. So sublimation is a physical change only because it's reversible. Okay, so that is the point right there. Let's take another color. Okay, next. During the reactions of some metals with a dilute hydrochloric acid, following observations were made. So what are those observations? Let's see. Silver metal does not show any change with dilute hydrochloric acid, they are saying. What is the reason? They are telling that Ag, silver is Ag, right? Ag plus HCl gives rise to, actually this should be a capital C, will give rise to AgCl plus H2 gas. Okay, it should be there, it should have been like this, but there is no any kind of change because this reaction does not take place. This is because silver metal cannot displace hydrogen. We know, right, the reactivity series, silver and all are at the end, so they do not show any kind of change. So right. The temperature of the reaction mixture rises when aluminium is added. Temperature of the reaction mixture rises. Rises means, what does that mean? It is basically an exothermic reaction. Heat is released, so it's an exothermic reaction, that's the reason. The reaction of sodium metal is found to be highly explosive. You know, right, sodium is highly reactive. What are the other metals? Sodium is highly reactive, potassium is also highly reactive. So that's why they are stored in kerosene stoves. In the acid bases and salt chapter, I think it's given, or maybe metals and non-metals. Yeah, in metals and non-metals it's given. Okay, so basically they are highly explosive, so they are stored in kerosene stubs, and yeah, that's the reason. Okay, moving on. Some bubbles of a gas are seen when lead is reacted with the acid. So lead is Pb reacting with HCl. What does it give? It gives rise to PbCl2. You know how to balance it, right? I hope so. Plus H2 gas. This is a gas and H2 gas. So this reaction is taking place. Okay, so at the end of this reaction, some bubbles of a gas are seen. That bubbles are of hydrogen gas itself. Okay, so let me remove all of these. So these are the explanations of each of them. Again, let's revise. First thing is, silver metal does not show any change because silver is less reactive. Okay, it can't displace hydrogen to form AgCl as expected. AgCl should have been formed, but it is not happening. Next, temperature of the reaction mixture is increasing because it's an exothermic reaction. Next, the reaction of sodium metal is found to be highly explosive, means that it is highly reactive. That's why they're stored in kerosene stubs. And then bubbles of a gas are seen, which is hydrogen gas. Those are the reasons. Okay, now, okay, 32nd question. Okay, substance X, which is an oxide of group 2 element, is used intensively in cement industries. This element is present in bones also. On treatment with water, it forms a solution which turns red litmus to blue. Identify X and also write the chemical reaction involved in this. Okay, it's a good question. It's an application question. So oxide of group 2 used, okay, with this clues, bones, cement industry, you'll get to know that it's something related to calcium, right? This thing you should know. Okay, so the the substance X is calcium oxide basically. So that they're asking in the last, like when you react it with water, okay, basically they form calcium hydroxide. Calcium hydroxide is basic, isn't it? Hydroxide is always, it's a base. So calcium hydroxide is a base. That's why this red litmus is turning into blue color. And also it's used in the it's present in the bones also, and it is used in the cement industries. The cement industry, it's given as a small point, but based on that a whole question is asked. Okay, this question, write a balanced chemical equation for each of the following reactions and also classify them. So let's take only a few of them. I'll solve the first and second. I want you to solve the third and the fourth. Okay, lead acetate solution is treated with dilute hydrochloric acid to form lead chloride and acetic acid solution. So you should just write the reaction. Pb lead, right? Lead acetate, CH3 COO taken twice plus HCl gives rise to lead chloride, which is lead chloride PbCl2, and acetic acid CH3 COOH. Avoid a circle here. It should be a proper O. It should be a proper O like this. Okay, this is the reaction taking place right here. So isn't it balanced, like one lead? Let's just check. Chlorine, there is one chlorine here and two chlorine here, so chlorine is not balanced. Wait, let's just write it here. Okay, chlorine is not balanced. Carbon, there is 1 plus 1 2, 2 2 is 4. Here there is 1 plus 1 2, just 2. So carbon is also not balanced. Oxygen, if we see, 1 plus 1 is 2, 2 2s are 4, and there is again only 2 here, so that is also not balanced. So you can just drop a 2 here. Okay, so drop a 2 here and I think it will be balanced now. Okay, it's going to be balanced now, right? Okay, next question. I hope it was clear. Moving on to the next question. A piece of sodium metal is added to absolute ethanol to form sodium ethoxide and hydrogen gas. So sodium plus ethanol. In carbon and its compounds, you will get to know that. I don't know if this year you'll get to know, because of the pandemic season this part is removed, but all at the end means alcohol. Okay, alcohol's functional group is OH, so that's why I'm writing it as C2H5OH. Again, the nomenclature and all will be coming in that chapter only. This will give rise to C2H5, right? What is it? Sodium ethoxide, ONA, C2H5 ONA plus H2 gas. Okay, it's a very bad handwriting. Sorry. Okay, so now there is one sodium here and one sodium here, 2 carbons here, 2 carbons here. Hydrogen is 5 plus 1, 6. There's 5 plus 2, which is 7 here. It's not balanced. Oxygen is balanced again. So what we're going to do is, let's put a 2 here. Okay, so it's becoming 2Na, right? Okay, so because of that we'll put a 2 here, 2Na. Oxygen is becoming 2, so we'll drop a 2 here. So it's balanced now. It's clearly balanced. 2 sodiums, 4 carbons, and yes, it's already balanced. So this is the balanced equation. Again, I want you to solve this third and fourth question. It's very easy, because in these sodium ethoxide and lead acetate was there, I have solved it. Okay, next question. They have asked us to classify them. Actually, the first one is like a double displacement one, isn't it? The first one is like a double displacement one, and then the second one is also like a displacement one. Second one is just a displacement reaction, right? So that is just a point right here. I know you can do that. Okay, let's take this color. Okay, why do we store silver chloride in dark bottles? Right, so this is an application. AgCl, silver chloride, will actually decompose to Ag and Cl2. Okay, let's balance it. Right, so it's going to be decomposing. At what time, at what reactions or reaction conditions does this take place? It will take place in the presence of sunlight. So it's like a photochemical decomposition. So in order to avoid that, we don't want just silver and chlorine. Maybe there is applications of this AgCl, right? We use it in black and white photography as well. So in order to avoid its decomposition, they are stored in dark colored bottles. Okay, right. Balance the following chemical equations and identify the type of chemical equation. So let's just do a few of them. Let's do this one and this one and this one alternatively. So you can do first, third and the fifth. Okay, here it is a decomposition reaction as usual. Identify the type is, it's a decomposition reaction. Now there is 2 oxygens here, 1 oxygen here. So let's put a 2 right here. And again, mercury is not balanced, so put a 2 here. Hg is mercury, hydrogen. Okay, here there is 4 chlorines and there's 2 chlorines here. 1 magnesium, 1 titanium, 1 titanium. So to balance chlorine, I have to put a 2 here. To balance magnesium, I have to put a 2 here. So it's like 1 2 1 2, right? Yes, it's correct. And this is a type of displacement reaction. Okay, displacement reaction. Moving on, the last thing, this is a decomposition reaction. As soon as you see, you'll get to know. And the thing is that they might ask this question, why is like hydrogen peroxide also stored in dark bottles and all? Because it will also break down in the presence of UV, ultraviolet radiations and all. Okay, from the sun also you'll get UV radiations, so they are stored in dark bottles. Point to remember, and this is the equation. It will split to water and oxygen. Okay, 2 hydrogen, 2 hydrogen, 2 plus 1, 3 oxygens, and there is 2 oxygens here. So what we'll do is, you have to know this, we have to drop a 2 here, 4, so drop 2 here. Oxygen will be 2 plus 2, 4, and here there is 4. Balanced. So this and this we have done. Okay, so 36th question. Okay, 36. Right. A magnesium ribbon, of course the formula is Mg only, is burnt in the presence of oxygen to give a white compound X accompanied by emission of light. If the burning ribbon is now placed in the atmosphere, is in an atmosphere of nitrogen, it continues to burn and forms a compound Y. Write the chemical formulas of X and Y. So magnesium ribbon Mg in the presence of oxygen. I think this is the first experiment, right? Mg plus O2, it gives a dazzling white flame. This will give you MgO. Okay. So you have to balance it and write in exams. Balance it anyways. Okay, so compound X is magnesium oxide. Now if the burning ribbon, so let's take Mg and okay, let's write a new one. Magnesium is kept in an atmosphere of nitrogen with N2, it forms Mg3N2. How do I get to know it's going to form Mg3N2? Shouldn't it form Mg2N? That might be a doubt. So because crisscross method, magnesium's what do you say, the magnesium's charge is +2, nitrogen you'll get it as 3. Okay, crisscross, so you'll get Mg3N2. So that's why Mg3N2. Okay, write a balanced chemical reaction equation when X is dissolved in water. So what is X? This is X. Magnesium oxide is X. So they are asking an application of magnesium oxide, which is MgO plus water. MgO plus H2O. Oh god. Okay, it's going to be forming magnesium hydroxide. It's dissolved in water and it forms a base which is magnesium hydroxide. What is the other name of magnesium hydroxide? Milk of magnesia, and it's used as an antacid. Whenever you have a stomach pain or something, you can have magnesium hydroxide. Okay, so moving on. Okay, so let those be there, right? Which color? Okay, blue. Zinc liberates hydrogen gas when reacted with HCl, whereas copper does not. Explain why. So any such kind of questions, right, you'll get to know easily that it's something about the reactivity series only. You have to know reactivity series, but here in the question itself they have described everything. You should just explain why, so it's easy. Zinc liberates H2 gas when treated with HCl. So HCl, that's a wide H. HCl with zinc forms zinc chloride, ZnCl2, and hydrogen gas. Okay, so it forms this, but copper does not react because again copper is below hydrogen in the reactivity series and it can't displace hydrogen in the top. Okay, so that's the reason. So that's it, not much in it. Next, silver articles generally turn black. Silver articles, note the point. When kept in open for few days, the article when rubbed with toothpaste again starts shining. So why do silver articles turn black when kept in the open for few days? Name the phenomena involved. So this is the question, and it is easy that this is due to corrosion. Corrosion. It's better I don't write. It's corrosion. Okay, so the turning of the color into black one is because of corrosion. Okay, basically metals such as silver and all, they'll react with moisture, acids and gases around it, and it forms some kind of layer on top of it, like iron forming rust. Like that, silver forms black coating. So like if you buy any kind of silver from the jewelry shops, and if you keep it for a long time, right, if you store it for a long time, then you'll get to know that some sort of a black layer is formed. It's because of that only. Name the black substance formed and give its chemical reaction. Here many people make a mistake. They think that silver will react with oxygen. Actually, you think that silver reacts with oxygen to form Ag, silver oxide, Ag2O. But this is not the reason. This is wrong. It will react with H2S. What is H2S? Hydrogen sulfide. This is all H2S. This is present in air and it forms Ag2S. This Ag2S is the one with black coating. Okay. This is asked in MCQs also. This is the one that is the black coating. Very important to be remembered. Don't forget, it's H2S. It's not oxygen. It's not reacting with oxygen at all. If it's a new information, then it's a piece of information. You have to remember it. Very important. Moving on. It was, by the way, it was asked even in competitive exams as well. Right. Okay. Oh, we have reached the long question and answers. Great. So I think this session was a good one. Is a good one. Okay. On heating blue colored powder of copper nitrate in a boiling tube, copper oxide black color, oxygen gas and a brown gas, X is formed. So some mystery. What is the X we have to find? Okay. Write a balanced chemical equation of the reaction and identify brown gas X. Identify the type of reaction. What could be the pH range of aqueous solutions of the gas X? Simple question. Copper nitrate. Cu, copper nitrate, CuNO3 taken twice. Okay. This copper nitrate is being heated. This is similar to another reaction. You have read it in the textbook. You have to remember that, recall that. It's gonna form copper oxide. Okay. CuO. I hope the handwriting is not disturbing. Copper oxide and oxygen along with what gas is formed is NO2. If you have read the study material and all properly, you will get to know that it's NO2. Brown gas NO2. First chapter brown gas NO2 only. You'll get to know that. So balanced equation they are asking. Okay, so checking copper 1, nitrogen 2, nitrogen 1. So we have to balance that. Oxygen, if you see, there is 3 2s are 6. Here there is 2 plus 2 is 4. 4 plus 1 is 5. So because of that, first let's put a 4 here. 4 2s are 8. 8 plus 2, 9, 10, 11. So mostly try to avoid those odd numbers. Okay, 11 which we are getting as a sum is an odd number. So let's put a 2 here. Okay, so you'll get 12 basically. So because of that, 3 2s are 6, 6 2s are 12. Now everything is balanced. You see, copper 2, nitrogen is 4 nitrogens, oxygen again 4 2s are 8, 8 plus 2, 9, 10, 11, 12, 3 2s are 6, 6 2s are 12, balanced. This is done. Identify X, it's NO2. Identify the type of reaction. What is it? In the presence of heat, decomposition reaction is taking place. What could be the pH range of aqueous gas X? pH range. What to do here? Nitrogen is a non-metal. So oxides of non-metals are always acidic. Okay, and oxides of metals are always basic. So this is a normal thing. So there are even amphoteric oxides. You might be knowing that already. NO2. So as it is acidic, the pH range will be less than 7. Okay, the pH range you know, right? Less than 7 is acidic, at 7 is neutral, more than 7 is basic. So the application of that as well. Okay. Okay. Give the characteristic test for the following gases. So carbon dioxide, sulfur dioxide, oxygen and hydrogen. You have to tell the test how to identify them. Carbon dioxide will turn lime water milky. Lime water, it will turn it milky, right? Calcium hydroxide, when you add it to that and all, it will turn it milky. So this is the basic thing that you will be already knowing. Okay, next, Sulfur dioxide, it will have some kind of a rotten egg smell. Even H2S also, it has somewhat a bad smell, like a rotten egg. You would be knowing that if you have tested in laboratories and all. Oxygen, what will happen is, for oxygen, suppose in a test tube it's being released, what you do is take a burning candle or some kind of splinter in the mouth of the near the mouth of the test tube. Don't place it towards your face, it might backfire on you yourself. Okay, place it away from you. Then what will happen is, suddenly the flame will start burning more vigorously, it will become more vigorous. So by that you'll get to know it's oxygen, because oxygen supports combustion, right? So it's the application of that. H2 will put off a burning candle with a pop sound. Okay, same thing here also, you place a candle but it will put off the candle with a pop sound. The same thing with carbon dioxide, if you see, it will extinguish the flame. That is also a test for carbon dioxide. Okay, if you place the candle, it will put off the candle with a, it will just put off the candle. Okay, with the pop sound means H2, if it burns more vigorously it's oxygen, and if it puts it off normally then it's carbon dioxide. Okay, what happens when a piece of zinc metal is added to copper sulfate solution? So let me just tell it orally. Zinc plus copper sulfate, this is like a displacement reaction, right? So zinc will displace copper, zinc sulfate and copper is formed. Simple. Aluminium metal is added to dilute HCl. So let me write this one. Aluminium with HCl. Okay, it's gonna be forming AlCl3. What is it? Aluminium chloride and H2. You can balance it. I know you all know to balance. So balance it, and it's about this. Okay. Silver metal is added to copper sulfate solution. Also write the balanced equations in each reaction. You should write the balanced equation, that you know that. Now silver metal is added to copper sulfate solution. Don't like blindly write it like silver sulfate and copper is formed. No. Here no reaction will take place because silver cannot displace copper. Silver is below copper in the reactivity series. Remember. What happens when zinc granules are treated with dilute solution of each of them? And also write the chemical equations if reactions is involved. So if reaction takes place, write the equation. So let me just tell it. Zinc with H2SO4 will form zinc sulfate and H2. Okay. So this is sort of like a displacement reaction. It is a displacement reaction. Zinc plus H2SO4 forms zinc sulfate with H2. With HCl, it will form zinc chloride and H2. Zn plus HCl forms ZnCl2 and H2. With HNO3, it's a different case. It's not zinc nitrate and H2 gas. That's not the case here. What happens is, here zinc reacts with HNO3. Zinc reacts with HNO3 to form, what are the things that are formed? Zinc nitrate is formed. Okay. ZNO3 taken twice is formed. Along with that, water, here water is formed, and gases like N2O, NO2 and all of that are released. So that's the case of HNO3. With NaCl, there is no reaction because sodium is highly reactive. Zinc cannot displace sodium over here. Okay, so it's like that over here. But with NaOH, don't treat it like sodium is highly reactive. Here treat it as a base. It's like a metal reacting with a base. Okay, so it's a metal reacting with a base. So it's gonna form sodium zincate. Okay, so sodium zincate and H2 gas, Na2ZNO2. Na2 ZNO2 and H2 gas, hydrogen is liberated. So let's start with the 43rd question now. On adding a drop of barium chloride solution to an aqueous solution of sodium sulfide, white precipitate is obtained. So we have to see this. Firstly, we'll write the equation involved here. Barium chloride, BaCl2, reacts with aqueous sodium sulfide, and it's a simple double displacement reaction taking place. Barium sulfite and NaCl. So first question is, write a balanced chemical equation. Oh, the line is too... Okay. Write a balanced chemical equation of the reaction involved. So I think you can do that. So you do it by yourself. Now, what other name can you give to this precipitation reaction? So, precipitation reactions, another name is the double displacement reaction, and also here double displacement reaction is involved. Barium takes place of sodium, sodium takes place of barium. On adding HCl to this reaction mixture, white precipitate disappears. So here the precipitate barium sulfate. So this barium sulfate is disappearing. What happens? What is exactly happening here? Barium sulfate in this, once the reaction has taken place, the reactants are totally consumed and the products are formed. That time if you use HCl, dilute HCl, what is going to happen? You're gonna get barium chloride, BaCl2, and BaCl2 water and SO2. Okay, so this is a reaction that's involved here. Barium chloride, water and CO2 is being formed. So basically again, barium sulfate is here being consumed. This is the white, this is the one that is causing this white precipitate, right? This is the one that is the white precipitate. When that is being consumed, it's slowly disappearing and it's going to form its respective reactants, respective products. Okay, so that's the thing involved here. Moving on, last question. Hip hip hooray. Okay, maybe we might require some space for this question. Right. Last question. You are provided with 2 containers made up of copper and aluminium. You're also provided with solutions of dilute HCl, dilute HNO3, ZnCl2 and water. So basically it's the question that in which containers you can store them. Okay, so this is also an important question. It's like a daily life application over here. Okay, copper, basically what happens is copper will not react with HCl or HNO3. So it will not react with this copper we are talking about. Copper will not react with HCl or HNO3. So it's good to store over there. But what about aluminium? Aluminium is more reactive than copper in the reactivity series. So you have to place these acids. The 2 acids should be placed in copper because we don't want something reacted, right? We don't want a reacted product to be stayed in the containers. We want the original ones. So to avoid the reaction, you should store them in the ones where they do not react. So store these HCl and HNO3 in the copper container. Okay, now copper being a less reactive metal compared to zinc, you can store zinc chloride in copper container. But what about aluminium? Aluminium is more reactive than zinc. So here zinc chloride cannot be stored because aluminium will displace zinc and you'll get zinc chloride and all of those things will happen. Now for water, we know water does not react that much. Okay, so you can store copper and aluminium in it. You can store water in copper container or aluminium container. The better one is copper. So that's about this question, and this chapter is completed. I hope you have enjoyed the chapter and the session, and we are done. From tomorrow or from the next video we'll be doing acid, bases and salt. So definitely spread the key of success, spread knowledge. Thank you.